Retrofuturism to the rescue. Or chasing all the bugs. Instead of talking about how computers are broken, let's talk about how to fix things. Let me open with an example of a fixed thing for a change. Everyone's favorite world encyclopedia is actually a fixed thing. It is a constantly self-updating system, and with AI and large language models, it will only get better. We need to fix smartphones, and we need to do it fast. We have to rebuild all the apps the way the collaborative editing rebuild the encyclopedia. And we have to address the fact that there is no one way of doing things, that different people want the same apps to have different functionality. An app, therefore, should be a set of visual programming nodes or puzzle pieces that can be fully customized and then assembled into precisely what the user needs. The visual programming language is only one button click away from the end user interface. Thus far, shallow greed and corporate short-sightedness, forced centralization and walled gardens under the guise of security and quality. Ecosystems are meant to be installed on the phone, where they don't need a central server. They will just need a copy of all the databases and access to remote APIs or functions, if needed. The databases are copied incrementally. It's efficient and wise. The new apps, aside from being greatly aided by large language models, will be built with a visual programming language, where nodes are coupled together to create new things. And it is nodes all the way down where a clever data stream-based programming language resides. Basically, everyone gets a copy of the encyclopedia of apps and the ability to customize them all the way from the bottom up. Visual programming is not hard. It is just a stream of data packets flowing through a diagram that lives beneath the apps. Performance is a weird thing. To start at the right point, we actually have to go back to 70s, 80s, and the 90s, to what is known today as retro computing, where if you wanted to drag a window, all you got was an outline of the window, and when you let go of the mouse, wherever you place the outline, that is where the window jumped. This is because animation and dragging and live previews eat up CPU cycles. And you don't have to use such features. The visual programming language is progressively enhanced to look as pretty as you need it to be. But the retro stuff is deeply needed so that low-power computers become snappy and responsive. The retro displays of green vector lines are back, and they make today's technologies look beyond bloated. There is no comparison. Also, there's one curious side thought. The high-contrast graphics configured to run on low-powered computers look really, really great on laser displays that project a laser on a wall. And that's it. You thought there was more to it, but no, that's it. That fixes all the computer problems. A fast, powerful, distributed, decentralized visual programming language is all that is needed. It takes very little to learn how to use it. It is just an interactive diagram, an editable application, an interactive concept map. It's so helpful that everyone can learn as they go. Above all the efficient graphics and user interfaces, live the beautiful apps, the end-user user interface. And they can be styled every which way. They can even be made consistent across all the applications, or as unique as their users need them to be. I personally envision fantasy retro-futuristic designs. But any design can be put on top of the vectors. It's really up to the user what theme they choose and how they style their apps, how they remix them to make them their own. Outside of speed and efficiency, a major point behind this system is the return to a state where users are not being analyzed all the time. Whatever privacy is taken away, sooner, much sooner than later, it will be sold or leaked or hacked and put in the hands of criminals. Everything being broken means that everything gets hacked all the time. It also means everything needs to get fixed now. Because signing binaries and walled gardens, closed source code operating systems are just too vulnerable, too broken, too easy to hack. We need to show the programmers that they can do better by helping them to a diagram-first system design approach that revolves around stream processing, something that is far more efficient than common programming. And since visual programming is all just about labels and lines and how to connect them, we might as well learn how to create programs as well.